1.
Hi, I'm Nathan Palayo, and I'm here to talk to you about question 1 of the limiting reagent and percent yield practice worksheet. Alright, let's begin with part A. Part A asks us to write the balanced equation for the reaction given above. So, as you can see, I've already balanced the equation here. The equation is copper chloride plus sodium nitrate, and then equals copper nitrate plus sodium chloride. And so we have I have this chart here that I've actually set up for us to see. We have two coppers. We have one copper. We have one copper on each side. We have two chlorines on each side. Chlorine and chlorine. Chlorine, and then this two is the chlorine. Two sodiums. So two sodiums here. Two sodiums here. And two nitrates. So we have two nitrates here, two nitrates here. And so now we balance our equation, we can actually move on to part B of the question. Part B asks us if 15.0 grams of copper 2 chloride reacts with 20.0 grams of sodium nitrate, how much sodium chloride can be formed? So we're actually going to start here with the grams that were given for copper chloride. So we were given 15.0 grams of copper chloride. So what we're gonna do is we're gonna multiply it. We're gonna divide it by the molar mass. And so what we had to do was we had to find the molar mass of copper chloride, and that's when we're gonna actually use our periodic table. And so it's 1 copper, 2 chlorides, and we're able to get 134.45. Now we're going to multiply this by the ratio, and it's 2. The top number is always the ratio of the number we're trying to find, which is sodium chloride in this situation, and the bottom number is the ratio for the number that we know, which was copper chloride. So for every 2 molecules of sodium chloride, for every 1 mole of sodium chloride, there is 1 mole of copper chloride. So for every 2 to 1, you know what I'm saying? So there's that, and then we're gonna multiply this by in the end we multiply this by the molar mass of sodium chloride, and so we have Na and Cl, and so that's pretty self-explanatory. So you're adding the atomic mass of sodium and chloride, and we're going to get 58.44. Now, right now you pull out your calculator, and you're going to multiply all the top numbers, and then divide it by all the bottom numbers. And then when we do this, we will result in the number 13.0 grams. So we're going to round off right here because of significant figures. There are 3 significant figures in this original number. So we have 3 significant figures in our product. Now moving on to the second part, we are actually now we have to do the exact same thing. I'm not going to get too deep into it because we just did the same thing. But we're going to do the exact same thing, but with sodium nitrate this time. So sodium nitrate, which is 20 grams, which they gave us. Then 85 is the molar mass, and that was 1 Na and 1 nitrate and 1 nitrogen and 3 oxygens, and we got all that together was 85. That was the molar mass. Then it was 2/2, and that's the ratio from this number and this number. You can see I put 2 2's in front of them when I balanced. And then we're going to use this exact same number because this is the molar mass of sodium chloride. We're using this again because we're still trying to find out how much sodium chloride we're going to get if we use sodium nitrate. And so with this one, when we multiply all the numbers at the top and we divide by all the numbers on the bottom, we get 13.8 grams. And that actually takes us directly to the third part of our problem. Part C asks us, what is the limiting reagent for reaction for the reaction? So right here in part B, that's what it's asking. So the limiting reagent if you guys don't know, the limiting reagent is the reagent is the reactant that, or the reagent that what's it called, limits the amount of product that can be made. And so kind of like when you're cooking and you have enough ingredients to make 50 cookies except for sugar. You only have enough to make 10 cookies, and that is your limiting reagent in that situation, because everything is being held back by the sugar, and so you can only make 10 cookies. In this situation, copper chloride is our limiting reagent, because what we're going to do is we're going to look at these two numbers here, and whichever number is the smaller number, that's the number that is the limiting reagent. And so we can tell 13.0 is smaller than 13.8, and that makes it our limiting reagent. Alright, so now that we have that out of the way, part D asks us how many grams of copper 2 nitrate, how many grams of copper 2 nitrate is formed. Now copper 2 nitrate is this fella over here, and we're actually going to do the exact same thing that we did for sodium chloride. However, we're doing it for copper nitrate. So it's asking us to do this again, but for copper nitrate. And it wants us, and in the end, so we're going to get two answers as well. So as you can see, I put both of the grams, the original grams I had here. This is copper chloride. This is sodium nitrate. This is both of their molar mass. This is the ratios, and then this actually is a new number here, but this is the molar mass of copper nitrate. So we got one part copper, 1 part nitrate. So it's actually 1 part copper, 2 parts nitrate, and 6 parts oxygen, because the 2 gets distributed into the parentheses. And that results us in 187.57. And so when we multiply all the numbers on the top and divide all the numbers on the bottom, we get 20.9 grams when we're talking about copper chloride. But when we react with sodium nitrate, our solution is 22.1 grams. So once again, copper chloride is our limiting reagent. Once again, just like how it was in the previous one. And you always want to do it even because the limiting reagent can be different depending on which molecule you're talking about. So you always have to do 2. Alright, so we're moving away from that, and we're actually going to talk about part E kind of ties this together and asks us how much of the excess reagent is left over in this reaction. So I had a little tough time with this one, but I think I understand it now. 15. So what we're going to be doing is we have to figure out, I guess, how many grams is in excess. How many grams is left over from the reaction, kind of like wasted. And if you want to think about it like this, when sprinklers go off, not all the sprinklers get into the grass. Not all the water gets into the grass. Some of it gets, like, not every single molecule of water, penetrates the soil and feeds the plants. Some of it runs off in the concrete. Some of it, goes in, it goes in unfertile soil. That's kind of like that's our leftover. It's our wasted. So what we're gonna do is we're actually gonna use the same equation, but we're gonna use copper chloride here, which was our limiting reagent, and we're actually going to be doing this to sodium nitrate. And so we have this. This. This is the ratio, and then 85 here is, you might recognize it from over here, and this is the molar mass of sodium nitrate. So as you can see, we're doing that same equation but up here, and we end up with, when we account all. Oh, this is not right. It's 19.0. So in the end, because of sig fig rules, we have 19.0. So then what we're gonna do to this number is that we're actually gonna take the original how many grams. We're gonna take how many grams of sodium nitrate we had in the beginning. And if you guys remember, we had 20 grams of sodium nitrate. So we take 20 and we subtract by 19, and we end up with 1 gram. And that 1 gram is our, I forget the name, it is the excess reagent. It's how much of the excess reagent is left over. So that's how much of it is left over. So 1 gram is left over. Alright, so the final part of this question is part F. And part F asks us, if 11.6 grams of sodium chloride are formed in the reaction described in part B, then what is the percent yield of this reaction? So what we're going to do is we're actually going to take 11.3 and okay, so what we're going to do is it's 11.3, which is the number that it gave us, and we're going to be dividing this by 13.8, which is this number up here. That's going to get a result as 0.81. And we can change that into a percent because it wants to know the percent yield of this reaction. So we move the decimal twice back, and it becomes 81%. And that is question 1, everyone. Thank you so much for watching.